Okay, so we're talking about inverse functions, and clearly there is an inverse sine function. Now, there's a couple of ways of writing it. We say y equals inverse sine of x. Well, actually, let's start off with our original function. We said let f of x be the function sine of x, right? And we're interested in finding its inverse. Well, the typical method for finding an inverse is to replace f of x with y, switch the x and y values. X is equal to the sine of y. And so what we would state right here is that as long as we limit our domain to being from negative pi over 2, less, not a comma, to positive pi over 2, then we can say that when we switch our x and y values right here, that at y will be between negative pi over 2 and positive pi over 2. And y could be expressed one of two ways if we isolate it. We say inverse sine with a negative 1 of x, or we can write it this way. Y is equal to the arcsine of x. Both are the same, mean the same thing. So our inverse function right here, and I'm going to stick with arcsine for the moment, is arcsine of x. Arcsine of x. Okay, so what does that relationship represent, right? If we say y equals inverse sine of x or y equals arcsine of x, what does that represent? Well, don't forget that when we said y equals sine of x, y, sine of x, is the ratio of a right triangle's opposite side to its hypotenuse. Opposite side to hypotenuse. So whatever value of x we have right here, that angle would have been. So in this relationship right here, this is the one I'm going to deal with right here. If I say y equals inverse sine of x, how could I state what y is? Well, y is the angle contained inside this right triangle whose ratio of opposite side to hypotenuse is x. All right, I know that seems a little weird, but if we stay between angles between negative pi over 2 and positive pi over 2, we basically have it, right? Right here, if we had a negative angle, it would work the same way, right? If we said y was this angle in standard position between negative pi over 2 and positive pi over 2, then the ratio of opposite to hypotenuse is still x over 1, right? X could be a negative value in this case, so we might say, okay, this is what happens when x is less than 0. This is what happens when x is greater than 0. Still, this whole thing fits. So, there we go. This is what that relationship stands for right here. Well, now there's more to say, because we should, based on that reasoning, be able to give some definitions of our inverse sine function. So I'm going to stick with my inverse sine notation for the moment. Y equals inverse sine of x is defined this way. Y equals inverse sine of x if and only if x is equal to the sine of y. In other words, y is the angle whose sine would be x, right? That would be a good way of reading this. X has to be between negative 1 and 1. Why between negative 1 and 1? Well, don't forget that was our range of our principal domain sine function. And y, as we've stated, is between negative pi over 2 and positive pi over 2. Visually, a way that I like to think about this is that, well, this means that we have to pick angles that are only in the first and fourth quadrants, and if it's in the fourth quadrant, it's a negative acute angle between 0 and negative pi over 2, and if it's in the first quadrant, it's a positive acute angle between 0 and pi over 2. So our inverse sine function range can be thought of as just covering these, and we don't have any angles that come from the inverse sine here in the second or third quadrants. Pardon me. Okay. How about inverse cosine? Well, y equals inverse cosine of x if and only if x equals cosine of y. That is, if you see this relationship, and by the way, the alternate on this is to say y equals arccosine, arccosine of x. Arccosine, there's two c's there, arccosine of x, right? Anytime we see this notation, we say that y is the angle whose cosine would be x. That means that if we were to draw a right triangle somewhere in our quadrant, we would have the adjacent side for x, right? So now, if we think about this, x is between -1 and 1. Remember, that was the range of our original sine function. And y is between 0 and pi. So in this function, we stay between 0 and pi, first and second quadrant angles, right? Because that's where we get positive and negatives for our cosine. We will not be able to use an arccosine function and find an angle whose value lies automatically in the third and fourth quadrants. That's a little bit of a different story. We'll have to treat that separately. All right. How about inverse tangent of x? Well, y equals inverse tangent of x if and only if x is equal to the tangent of y. That is, y is the angle whose tangent would give you x. Now the notation for this one is alternately y equals, you guessed it, arctangent of x, arctan x. Right? X can be between negative and positive infinity, right? Remember that was the range for our principal domain tangent function, and the angles have to be between -pi/2 and positive pi/2, but not include those angles. So I'm going to put a big open circle here and a big open circle here and make it look like that first drawing up there for tangent, only this time our arctangent is going to give us a negative acute angle between 0 and -pi/2 if it falls in the fourth quadrant, or between 0 and positive pi/2 only if it falls in the first quadrant. We will not get arctangent angles that fall anywhere in the second or third quadrant. All right, so these are our principal definitions for the arcsine, arccosine, and arctangent functions.